The number of days that elapse between the beginning of a calendar year and the moment a high-risk driver is involved in an accident is considered to be a random variable with PD of 1 over c e to the power of x over c. An insurance company expects that 30% of high-risk drivers will be involved in an accident during the first 50 days of a calendar year. What portion of high-risk drivers are expected to be involved in an accident during the first 80 days of a calendar year? So the first thing to note is that the PDF is the probability function, and it means that we have 1 over c e to the negative x over c for x being greater than 0 and 0 otherwise. Okay, so this is the PDF function that we should use. Now it says the insurance company expects 30% of high-risk drivers will be involved in an accident during the first 50 days of a calendar year. So what it means, it's another way of saying that in the first 50 days of a calendar year, the probability of a high-risk driver to be involved in an accident is 30%, right? So we know that we can set 30% as 0.3, basically 30 divided by 100 gives us a number, and this is equal to the probability, right? And the probability can be derived by this function, right? We have to integrate this function from 0 to 50 with respect to x. From 0 to 50 because we're talking about the first 50 days of a calendar year, right? So we start to count from 0 and we go to 50. Okay? So now, obviously, to find the portion of high-risk drivers that are expected to be involved in an accident during the first 80 days is going to be similar, right? We're going to integrate from 0 to 80. But before we do that, we have to find the value of c. And as you can see, since we already have the probability set to 0.3, we can solve for the integral here and then find the value of c that way. Okay? So we know that we can place 1 over c outside of the integral, and this is going to be e to the negative x over c dx. The u substitution yields us u is equal to negative x over c. The du is going to be what? Negative 1 over c dx. Okay, so obviously there's 1 over c there, but there's no negative, so we have to have a negative sign. Okay, and notice that if you change the limits as well, because you have to change the variable, you're going to have integral from 0 and then 50 will be the x, so it's going to be negative 50 over c, right? Because when you set x is equal to 50, you're going to have negative 50 over c as your upper limit, and this is going to be e to the u du. So then obviously what are we going to have? We're going to have minus e to the u, right? Because e to the u, the integral of that is still e to the u, and the minus sign holds, right? So it's going to be from 0 to negative 50 over c. Okay, so then we can place the minus, we can have e to the negative 50 over c minus e to the 0, right? So what are we going to have? E to the 0 is 1, 2 negatives gives us a positive, so we can place 1 first, even though it's a second term. And then minus e to the negative 50 over c. Now this is equal to 0.3. Right? If this is equal to 0.3, that means e to the negative 50 over c is going to be equal to 0.7. Right? Because if you subtract 1, you're going to get minus 0.7, and then you're going to multiply by negative 1 both sides, you're going to get this. So now, to solve for c, you need to use the ln. Taking the ln on both sides gives you this, right? And that means that negative 50 over c times ln e is equal to this. Ln e is 1, so we don't have to write that down, so this is equal to ln of 0.7. So that means c is equal to the negative 50 over ln of 0.7, right? So this is just the algebraic manipulation. So now we found the value of c, so we can integrate from 0 to 80, and we're gonna find the percentage, right? Because the portion means that we're gonna find percentage. Portion means percentage, right? This meant that this was 30%. The portion of high-risk drivers was 30%, and we're gonna find the percentage for 80 days, right? So the percentage is going to be from 0 to 80 of so 1 over c means that we're going to flip this, right? So we're going to place a minus outside, and actually why don't we place the ln, outside as well, right? Because this is a constant, right? So we have to flip this, and so it's going to be minus ln of 0.7 divided by 50, right? Multiplying the integral, and this is going to be e to the negative, let me see, so negative with that negative, right? Because there's a c involved in there, will give you positive, right? So we can cross that out, and we're going to flip this, of course, so that's going to be ln of 0.7x divided by 50, and this is all a power, keep in mind. Okay, so now the good thing is that if you use the u substitution, the du is already there, except there's a minus, right? So as a result, you're going to have a minus, right? Minus e to the ln of 0.7 over 50x, right? So from 0 to 80. It's going to be similar to this. Okay, so what are we going to have? We're going to have minus, we can place the minus outside, e to ln 0.7 divided by 50 times 80 minus e to the 0, right? Because the 0 in the x cancel these guys out. These numbers, they don't matter anymore, right? So what is that going to give us? That's going to give us 1 again. 1 minus e to the ln of 0.7 multiplied by 8/5, right? 80 divided by 50 is 8/5, right? So that's going to be 8/5 in that power. So what is that going to give us? We can find that out and see if it makes sense. So 0.7 ln times 8 over 5, that's the power. Raise that to the e, and then negate that, and then plus 1 gives us this answer, 0.434858937. And the answer choices, which I didn't provide here, will have the correct answer choice. They will not be very close to this answer. You will recognize it immediately that it's going to be rounded to the nearest hundredth at 0.43, and that will be the answer choice provided to you in this question. Okay, so I hope this was fun and helpful. Thanks for watching. See you in the next video.